they observed distant galaxies with the James Webb Space Telescope and discovered something utterly surprising. The common understanding was that the universe underwent rapid expansion before cooling down. Then, the first stars and galaxies started to form, during a time we call the Dark Ages. But here's where scientists started scratching their heads. These ancient galaxies looked as developed as our own Milky Way. It's even much more mature than astronomers anticipated, which could only mean one thing: that they must have existed way before our galaxy. Now, why is that a big deal? Apparently, this finding of ancient galaxies is going to challenge our understanding of how the universe began.
There is a Big Bang, but the Big Bang was not the beginning. People tend to think that if you have a model in which it keeps on going in some sense, and your Big Bang is not the beginning, that you've got to collapse back.
So, a fundamental question arises. Is it time to reconsider what we think we know about the Big Bang and the origin of time? Before the early 1900s, most scientists thought the universe was static and unchanging. It means no expansion, no contraction, or any other changes taking place. But all that changed about a century ago. Astronomer Vesto Slipher noticed some nebulae were moving away rapidly. He first thought it was because of our galaxy's motion, but more observations from the Lowell Observatory in Arizona didn't support this idea. That's when Edwin Hubble stepped in. He showed a clear pattern that the further away a nebula was, the faster it moved away from us. And what's more interesting is that these discoveries matched what general relativity predicted, that space-time could stretch or shrink. And so, if we trace back the universe's expansion using Einstein's equations, we land on the idea that all space, mass, and energy were once squeezed into a tiny point, a singularity. We often hear that the universe began with this singularity, followed by the explosive Big Bang. If we think about it, the scale of the universe is mind-boggling, and the events just before the Big Bang are still a mystery. Now, if everything started from that point, what existed before it? Was there really nothing, no space or time, before the singularity? In order to understand how the rewinding time went back billions of years ago, let's consider this scenario. Think of our universe like the surface of any balloon. Here we have to introduce the concept of scale factor. The scale factor is like a ruler to measure the balloon's size. Right now, our universe is blown up to a certain size, which we call one scale factor. But some time ago, this balloon was only half as big. Now, two dots will be drawn on this balloon, so if we blow it up, the dots move farther apart. And that's the expansion we mean. So in some future moments, the scale factor for this balloon will be larger than 1. Now think about letting the air out of the balloon slowly. As you do, everything on the surface comes closer together. If you could completely deflate the balloon, you'd have a tiny, flat piece of rubber. This is a bit like the singularity, when the whole universe was very close together, extremely hot and super dense.
If you extrapolate those equations back in time and try to predict what the conditions were at earlier times, you come to a moment 14 billion years ago when the temperature and density become infinite.
But just when you feel you've grasped this bizarre notion, it turns out the picture might not be so clear. Currently, there's strong evidence suggesting we shouldn't take Einstein's equations all the way back to a singularity. For instance, observations hint at a time, just before 10 to the negative 32 seconds, when the universe underwent a super-fast expansion, known as cosmic inflation. Cosmic inflation offers valuable insights into the universe's expansion at a vast scale. It tells us why the universe looks so consistent and how galaxies came to be. In a way, it solves several puzzles in the Big Bang theory. But still, the singularity is a condition of intense density on a minuscule scale, where quantum forces play a vital role. So, just using general relativity alone, we can't fully grasp the phenomenon of singularity. This early rapid expansion helps iron out issues with the Big Bang theory. We might need to rethink this whole Big Bang singularity concept, since it will probably reshape our understanding of cosmic inflation and the beginning of the universe. So, what truly unfolded at the start? It turns out that the peculiar nature of the Big Bang singularity suggests it might not be the whole picture. Mathematical singularities in a physical concept usually raise some eyebrows. They often mean the theory has gaps or has been pushed to its limits. And that's where we stand now. We've rewound the universe using general relativity, but this theory isn't all-encompassing. At the extreme densities and temperatures of the Big Bang singularity, general relativity clashes with quantum mechanics.
We're not really sure scientifically that there was a beginning to space and time. In fact, we've been exploring the idea that when you actually replace Einstein's theory with an improved theory of gravity, that you'll find that the Big Bang was not the beginning, that there existed space and time beforehand, and in fact, the key events that created the large-scale structure of the universe and even all the galaxies and stars, all those events actually occurred before the Bang. And we only exist here because of those events.
Sir Roger Penrose provided us with a new framework of thinking. He asked us to imagine what or who's in this universe eventually, if we fast-forward time to infinity.
Who's in this universe eventually? Not us. The black holes will all have evaporated away by Hawking evaporation. They've swallowed galactic clusters. What's left in the universe? Pretty well photons. That the photons reach infinity without realizing anything funny has happened, if you put it like that. Infinity in this conformal picture is just like anywhere else.
So let's imagine that matter in the whole universe will eventually be dominated by photons. As you might have realized from relativity, the trouble with photons is that they don't feel the passage of time. Why, you might ask? Let's break it down. Think of space-time like a grid in the fabric of cosmos. We can measure separation on this grid using the space-time interval equation. Here, the term tau is the time we feel, and the term ds squared is a variable to measure the space-time gap, or separation. For us who are stationary, our movement on this grid is all about time and not really about space. I mean, we're still traveling through time. So the equation now becomes this. It tells us that the separation the object travels in this combined space-time world is just based on time. This time distance relates to the speed of light and a special kind of time interval. Now, if we had something that could teleport, let's say in the x direction, its motion would be all about space. So we're left with this equation, which means two events in the space-time grid that happen at the same time, but at different positions in space. But photons are truly unique. They travel along a specific path known as null geodesics, a route taken by anything moving at the speed of light. What's fascinating is that photons move in such a manner that they don't experience time or space. They're instantaneous. This is why their space-time interval becomes d squared equals to 0. So imagine this. You turn on a flashlight briefly and then turn it off. The instant the light shoots out is event A, and the moment it reaches a certain point away from the flashlight is event B. The space-time separation between these two moments is ds squared equals 0. That's because the photon moves from A to B simultaneously cruising through both time and space, in a way that they offset each other. This unique way of moving means that photons lack a rest frame. They don't possess a personal clock as the rest of us do, so they never feel time passing by. This special behavior matches up with a fundamental idea in physics, that no matter where you are or how you're moving, light always moves at a consistent speed. If photons had a stationary reference point, it would appear as if light isn't moving from their view. This very fact contradicts our understanding of the speed of light. Also, the equations governing light are the wonderful equations due to James Clerk Maxwell, aka the Maxwell equations. These have a very interesting property. It lies in the fact that the equation couldn't tell big from small. The vastness of the universe, or the smallest quantum particles, are all the same if we use these equations. For instance, if you have a system in which you've got some electromagnetic field, and you could stretch this system to bigger or smaller, it wouldn't notice the difference. This phenomenon is called conformally invariant.
If you don't mind stretching or squashing, then you could step outside this universe to another side to it. So I want you to imagine the same thing here, that you've got the Big Bang, which is somehow stretched out to be a one-time surface, but you could go before it. This mathematical trick, if you phrase condition on your universe in this way, you say you could extend to before, then that is a way of characterizing the initial state of the universe.
As Penrose explained, if we put the concept of an infinite universe in this conformal picture, every conceivable space is just like anywhere else for massless object. Because essentially, it's only mass that knows the difference. So although massless things might perceive all spaces the same, they lack the ability to mark time. This is when Einstein's theory helps us track when the universe started. Einstein told us that energy and mass are basically two sides of the same coin. But another important equation came from Max Planck, who said that energy and frequency are linked, E equals hf. If we put these two equations together, we realize that mass and frequency are connected. This means anything with mass, like a rock or an apple, has its own beat or rhythm. And so without mass, we wouldn't have a clock or time. In the end, Penrose's argument eventually leads us to this, that the very remote future is indistinguishable from a Big Bang. When the universe has become basically empty except for photons, it would be as though it had transitioned into a new Big Bang phase. Our universe's future could become another universe's beginning. This concept, often referred to as conformal cyclic cosmology, challenges conventional ideas about the beginning and end of our universe.
About 12,000 years ago, there was a global cataclysm. Some kind of event melted the polar ice caps and caused a great flood. This was either an asteroid impact or more likely a major solar event. The flood caused sea levels to rise 400 feet and changed the face of the Earth. Millions of square miles of land were submerged. Cities were destroyed. The entire human race was almost wiped out. You can see this flood myth depicted in every ancient culture. The myth usually ends with a godlike figure emerging from the sea or from the sky to help mankind restart civilization. The Anunnaki gave the Sumerians instructions to escape extinction. These instructions are carved on the cylinder seals. When rolled in the proper sequence, the cylinders outlined a procedure to access naturally occurring wormholes. Now, these are portals, sometimes called stargates, that allow you to move to various points in space instantly, and there are about 50 of them all over the world. And since the cylinders were found to be alien, they were transferred to a group called Majestic 12. Majestic 12 was established in 1947 to take charge of the technical, biological, and all aspects of crashed UFOs. MJ-12 soon learned that UFO technology was compatible with the information on the Sumerian cylinders. By combining the ancient Stargate instructions with alien technology, MJ-12 was able to build a machine. Security measures at S4 were intense. Armed guards were everywhere. Every door required voice print identification or a retinal scan. Every day he'd have to go through a decontamination procedure, including a change of clothes, shower, and a shave. The floors of S4 were painted with parallel lines, one blue and the other red. Dan was told to stay within the blue lines and to never cross a red line. Guards were ordered to shoot to kill anyone who crossed the red line.
The good stuff is behind the red line, ain't it?
Will you let me paint the picture here?
Sorry, I'm just excited. Go ahead.
S4 had 5 floors, but you had to walk down from level 1 to level 4. The only elevator in the building was on level 4, which was the only way in or out of level 5. On level 1, Dan was given his security badge and shown the cafeteria. The dining hall had 4 round tables, each assigned to a different project team. He was to eat with the Aquarius team at their table. Meal times were staggered to minimize contact, but he was still reminded to not speak with members of any other project. The long hallway on level 1 passed a number of hangar bays on Dan's left. The hangars were on the other side of the red line.
I knew it.
The first few hangars were empty, but then Dan walked past the hangar that changed his life forever. He saw a disc-shaped object, a flying saucer. Later, Dan would learn this was a P-45 craft. A few more empty hangars and then another flying saucer. This one was a different type, a P-52. The last hangar held a craft shaped like a triangle. It was flat black and hovering a few feet off the ground. Level 3 was offices, conference rooms, and living quarters. Level 4, the Aquarius floor, was Dan's new lab. There, he was finally read into the project. Up until now, he didn't know what he'd be doing. He was just told it was exciting, important, and very top secret. As a microbiologist, he would be analyzing alien biology. Tissue samples, DNA, everything.
Hold on, you skipped level 2.
Right. Level 2 was strange. It was known as Alice's floor.
Alice, from the Brady Bunch?
No,
Oh, from Mel's Diner?
no. From Alice in Wonderland.
Oh.
Project Galileo was on this floor. That dealt with propulsion systems from alien aircraft. Level 4 was also home to Project Sidekick, an alien weapons program. On level 4, Dan saw a small plastic statue hanging above a door. It was a statue of the White Rabbit from Alice in Wonderland. The rabbit was wearing a red vest and holding a pocket watch. And if you follow the White Rabbit through that door, just like Alice, you step through the looking glass and into another. Inside the Project Looking Glass lab was a machine. The exterior of the device was a circular ring about 5 feet tall and 10 feet wide. It's made of a dark gray metal alloy with a smooth finish. This ring forms the outer shell. Inside the circular outer ring is a core made of several spinning rings. Think of the object in the movie Contact. It looked just like that, just on a smaller scale. These spinning rings were lined with powerful electromagnets. These created fluctuating electromagnetic fields around the center chamber. At the heart of the machine was a rotating metal barrel lined with quartz crystals. This central barrel is suspended inside the spinning rings using gyroscopes and a gimbal mechanism. Inside the barrel is a chair for the operator.
To do what?
Well, a few things. It really depends on the operator.
Yeah, I don't follow.
Well, over time, as the technology became more understood, the machines could be adjusted to do various things to warp space-time. Looking glass technology was used during the Philadelphia experiment. That project failed, but later the Montauk project was launched. And researchers learned that if a person with certain mental abilities was integrated with the technology, it could be controlled. Operators learned to see any place on Earth. You've heard this called remote viewing. All the operator would have to do is think of a place, and that place could be seen. Now, this was useful for intelligence gathering, but it was extremely helpful in locating more ancient Sumerian cylinders. Back on Alice's floor in the S4 building, technology from crashed UFOs was found to be compatible with the Looking Glass devices. Using this advanced technology, the Looking Glass operator could do more than see any place on Earth. The operator could see any time on Earth, the past, present, and the future. And if the operator was really talented, not only could he see the future, he could change it. The CIA has always been interested in psychics and psychic abilities. A psychic who could see anywhere on Earth is the ideal spy. Psychics were also useful for looking glass devices. In the 1980s and 90s, psychics were recruited or abducted for this purpose. A chair recovered from an extraterrestrial craft had technology that let the pilot sync his consciousness with the craft. This technology was integrated into the looking glass machines. The psychic operator would sit in the chair at the center of the looking glass device and activate the machine. The startup sequence charged the electromagnets surrounding the central core that were calibrated in specific ways depending on the mission. Then xenon and argon gas were injected into the rotating barrel. A grayish orb would form in front of the operator within the gas. This was a stable wormhole to the probability dimension.
That sounds made up, but I love it. What the hell are you talking about?
The looking glass machine allowed the user to see past, present, and future. Seeing the past is interesting, but seeing the future, that's useful. But not only could you see the future, you could see possibilities of the future. The operator would mentally focus on an action. The operator could then see the probable outcome of this action. Like, what would happen if we invaded this country? Or what would happen if this particular person was assassinated? The output was captured by cameras and relayed to view screens. The researchers could feed questions to the operator and instantly see the results. This was highly useful. What they reported seeing covered an enormous range, from disaster events and weather anomalies to political outcomes and earth changes. Soon, looking glass operators learned how to steer events toward a specific goal. There was a problem, though. Different operators would see different things depending on their own biases. Like a Christian looking backwards will see the crucifixion of Christ. Atheists would just see Jerusalem. Looking forward was the same problem. Operators were seeing different future outcomes. Physicists and computer scientists were brought in to develop software to stabilize the process. Computer programs could feed the operator a lot of questions very quickly, and the results would come back fast. It worked, and it was useful. For a few years, thousands of choices were fed to operators, and thousands of possible timelines were seen.